Yeah, we'll continue. So we are talking measurements. In the measurements, there are different physical systems, physical units, fundamental quantities, derived quantities, and units conversions, dimensional analysis, etc. So here we will take it as, see, the most, see, conversions like different units, power, the SI unit is watts, ergs per second, CGS unit conversions you take, the unit conversions, the last video continuation. So in that, if you observe carefully here, see, for example, 1 kilometer per hour is equal to how many meters per second, or 18 kilometers per hour. See, 18 kilometers per hour, 18 kilometers per hour. How many meters per second? 5, approximately 5 meters per second, because it is taken 0.278. See, similarly, if you try to find out, the another any, see, dynes per centimeter square, 100 dynes per centimeter square, if you try to convert 100 dynes per centimeter square, see how many pascals, 10 pascals, 100 dynes per centimeter square is 10 pascals. See here, if you observe the conversions you take, all conversions, different conversions are there. See, 1000 liters is how many meter cubes? 1000 liters is how many meter cubes? 1000 liters. See, meter cubes, 1 meter cube, 1000 liters is 1 meter cube. You can observe conversions can be done. See, these are all you should learn actually. See, 1000 kilowatt hour or 100 kilowatt hour, 1000 kilowatt hour, 1000 kilowatt hour is dash joules, megajoules, that is 3600 megajoules. 1000 kilowatt hour is 3600 megajoules. Conversions can be done. 1 electron volt, how many joules? 1 electron volt, let us take 1 electron volt. See how many joules? 1.6 joules. 1.6 into 10 power minus 19 joules. See, conversions, these can be converted. For example, see, 1 horsepower is how many watts? 1 horsepower, see, 1 horsepower is 745.8 watts. 745.8 watts. See, in this way you can do the conversions very clearly. You can also test. See, 1000 centimeter cube is how many meters cubes? See, in the physics is nothing but measurements and conversions. All these are very, very important. See, 1000 centimeter cube. 1000 centimeter cube is 0.001 meter cubes. 0.001 meter cubes. These are all conversions you take, all different conversions. Atmosphere, you can convert into kilopascals. 100 atmosphere is how many kilopascals? 100 atmosphere. Say kilopascals. 10130 kilopascals. 100 atmosphere is 10130 kilopascals. So in this way, you can have the different conversions. And the development of mechanical units. These are the development like length divided by time is speed, mass acceleration is energy, mass into acceleration is force. See, ml by t square, ml t power minus 2, that is force dimensional formula. So the unit tables in the last video discussed different units, unit tables, etc. So dimensional analysis. What is dimensional analysis? Dimensional analysis is nothing but, see, the different physical quantities you are expressing in terms of fundamental quantities like length, mass, time. So you are expressing into the fundamental quantities. For example, velocity. So that is unit is meters per second. LT power minus 1. Dimensional analysis can be done. Dimensional formula. Say centripetal force. Centripetal force. See, this is the centripetal force, mv square by r. mv square by r, centripetal force. So how to find dimensional analysis here? Force units is newtons, mv square by r, mass is kgs, see meter per second whole square, speed meters per second, meter per second whole square upon meter, kg meter per second square. Newton, 1 Newton is 1 kg meter per second square. You can check out the dimension by using dimensional formulas. We can check out whether these are dimensionally fit or not, these equations. See, similarly this force equal to qvb. The magnetic force, this is charge into velocity into magnetic induction. So 1 Tesla is equal to 1 Newton per, so coulomb meter per second, 1 Newton per coulomb meter per second. So coulomb meter per second is there in the denominator. So 1 Newton is coulomb meter per second Tesla. You can convert like this. All this can be done. Magnetic fields, all magnetic fields and other things, by using this you can have the conversions. Unit conversions we have seen already. Motion to energy. Motion to energy. Here, if you observe this, there is motion to energy, length divided by time, acceleration. You are going to get mass time. See, mass equal to here force, length, force into length, that is nothing but force into displacement, work is equal to energy. And if you take change in momentum is equal to mass into change in velocity, acceleration, mass into acceleration. See, like this, mass can be converted into energy, that is Einstein's equation, mc square, conversion, energy neither created nor destroyed. So law of conservation of energy. So this is motion energy equations like. So in the mechanics we have, there is physical units. In the physical units, unit conversions we have seen, table of units. Table of units are also we, and there are dimensional analysis, motion. See, overview of time. See, this is the just overview of time, a brief outline of time. So mechanics and motion, gravitational time, distance, comparisons, pendulum, by using pendulum, so we can have the time, gravitational time, aircraft experiments, etc. This is just explains about it. So time analysis and everything, is the time is immutable or not, all these things. See, these are the different phenomena like. See, mechanics, this is one physical units. Next one is we have, there are some conversion of loss. Conversion of loss, if you take, see, conversion of momentum, conversion of loss, conversion of energy. See, these are the things are there in the physics. Conversion of momentum, law of conservation of momentum, algebraic sum of all moments is equal to 0. Conversion of energy, algebraic sum of, see, something like energy neither created nor destroyed, energy remains constant at any place in the universe. So that's why, see, that is something like fundamental principles. Conservation of angular momentum, angular momentum is constant, angular momentum is constant. So these are all law of conservations in the nature, what in the physics, very very important. See, mechanics, basically this is having all these things. Coming to the index, in the index we have close this index. Yeah, see, go to mechanics, there we have the equations like, there are some physical constants are also there, the physical constants, the physical units only will be the physics, velocity and acceleration. Newton's laws. Yeah. Velocity, relative motion, some physical constants are there. No. Yeah. Yes, tables, different tables if you observe in the physics. In the physics, different tables, mechanical tables. These are mechanical densities, different densities. See, if you observe, the water density is 1 gram per centimeter cube. Water density 1 gram per centimeter cube. See, mercury density 13.6 grams per centimeter cube. Milk density 1.03. Different densities, magnesium 1.7, copper, like, see, gases, air density is this much, 0.001293. These are the densities of different and Young's modulus, there is a constant Young's modulus in the physics. So that Young's modulus constants if you take. Yes, Young's modulus is nothing but, see, something like the stress by strain. The stress by strain. So the stress by strain, the constant value for steel if you take, the Young's modulus value, the density is 7860 kg per meter cube. These are all tables, physical tables. Young's modulus is 200 into 10 power 9 Newton per meter square. The ultimate strength of the steel is this. Yield strength of the steel is this. So wood 525. Like this, these are the physical data we are supposed to have. See, sometimes in the problems they will be giving all these things. We should not get confused what are all these things. Similarly, compressibilities of the liquids. There are compressibilities constants. See, compressibility 93 into, so 10 power minus 11, 1 by Pascal. That is compressibility of carbon disulfide. Water 45.8. So like this, there are different constants, compressibility constants in the mechanics if you take. In the mechanics, these are the constants, properties of liquids, viscosity, all these are the index tables. If you go to index tables, optics, okay, every electricity, there are different constants are there, resistivity constants. The resistivity constants, these are the resistivity constants. Silver, the resistivity is ohm meter 1.59 into 10 power minus 8. Temperature coefficient of resistance, that is per degree centigrade, 0.0038 per degree centigrade. Copper, so aluminium, tungsten, these are the values you can observe here. See, conductivity value, temperature coefficient of resistance value, resistivity value, these are different tables. So different values of that constants. See, similarly, conductivity of element, just now ferromagnetic Curie temperatures, superconducting transition temperatures, dielectric constants. There is a dielectric constant, important constant in the physics. Dielectric constant of vacuum is 1. Dielectric constant of vacuum is 1. Mica is 3 to 6. Teflon is 2.1. Like that. See, all are different constants. So these constants are also very, very important. Since we are talking measurements, so these constants also we should have the idea. That is very, very important. Magnetic susceptibilities, magnetic properties, ASCII codes, magnetic susceptibility values, susceptibility value of paramagnetic materials like iron oxide, iron aluminum, these are the constant values. I hope you understand something in this video. These are all about constants in the measurements only. So fundamental physical constants. So the speed of light, that is 3 into 10 to the power of 8 meters per second, approximately, that is. So the Planck's constant 6.6 into 10 power minus 34 joule second, and you take, there is a gravitational constant 6.6 into 10 power minus 11 meter cube per kg second square. So, and Boltzmann constant 1.38 into 10 power minus 23 joules per Kelvin. These are the constant, different constants. You take permeability of vacuum 4 pi into 10 to the power of minus 7 magnetism, that is magnetism constant. Charge of electron 1.6 into 10 power minus 19 coulombs. Avogadro number 6.02 into 10 to the power of 23. See, these constants you should have the idea in the physics. Mass of electron, that is 9.1 into 10 power minus 31. So kgs. Mass of proton 1.67 into 10 to the power of minus 27 kg. All are very, very important constants. Mass of neutron is approximately same to mass of proton. See, mass of neutron, mass of proton in terms of mega electron volt per centi, so per c square, that is velocity of light in vacuum, that value is 938.27. Atomic mass units, Boltzmann, Stiff Boltzmann constant, Rydberg constant, that is the Rydberg constant value. See, just observe here, there are many constants are there in the Bohr's radius. So like this, the constants and all these things you should have the idea. Thank you very much. Thanks for watching this video.